All right, the background looks a little different here because we're going to do a little bit of graphing. Okay, we talked about slopes yesterday. We talked about, let's just do this real quick. If I had a slope like this, what do you know about that slope right now? Let's make that a little thicker. Yeah, it's a positive slope, isn't it? Okay, and if you had a slope that went like this, let's make it go like that. What kind of slope is that? It's a negative slope. What if you had a slope like this? Slope is 0, isn't it? Okay, it's a 0 slope. And so 0 is a number, isn't it? 0 does exist, so that's a 0 slope. And then if you had a line like this, what do we say this is? It doesn't exist, or it's undefined, or it's no slope. There's a lot of different ways you could say that. All right, but it doesn't exist. It's no slope. It's different from 0 slope. Everybody see that? 0 slope and no slope are not the same thing. Even on the honors test, when they did this chapter this year, a lot of people put no slope for this. All right, and some people put 0 slope for this. It's not the same thing. All right, this is 0. This doesn't exist. This is undefined, or it's no slope. And I understand why people would say that 0 and no slope are the same, because when you think of 0 something, you think it's nothing, right? But 0 is something, though. All right, it is a number. All right, you can add 0, you can subtract 0, right? You can even divide a number by 0, or not by 0. You can divide 0 by a number. Anyway, so 0 does exist. This doesn't exist. This slope does not exist. Everybody with me on that? And let's review just one more thing. We talked about how to find the slope. So if I had a line that looked like this, oops, don't want it to look like that, like this, right here. What did we do to find the slope? We took a point here, and we took a point here, and we figured out how far up and down, which is what, Javi? The rise, and then over would be the run. So this would be the rise, and this would be the run. So the slope is equal to the rise over the run, right? Let me give you something else I should have mentioned yesterday. See the word slope? They assign a letter to the word slope, and it's kind of weird that they would use this letter. But yeah, you've seen this before. It's M. M is the slope. Okay, they use the letter M. I actually looked that up. I Googled it because I had no idea for years and years and years. I never knew why they used M for slope. And people really aren't exactly sure where that came from, but they kind of think it comes from a Latin word it means kind of like mountainous, right? Because when you climb a mountain, it's steep, right? You go up a slope to a mountain. So it doesn't really stand for mountain, but it stands for a Latin word. I believe it's a Latin word that has to do with mountains and that kind of thing. Okay, so when you think of M, think of a mountain, think of a slope as you're walking up or down a mountain. That's how you can remember M. Is that all right? Okay, and again, I don't think people agree on it. I looked and I saw several different opinions about where that came from, and that's that. All right, so that's basically review from yesterday. Would you agree? Let's now do some actual numbers here. Let's make a X and Y axis. Let's make this a little bit thicker, and let's put it, let's see, about right there. Make sure it's right on the line, and oops, let's try this again. Oops. What am I doing? Why isn't it? That's good. And let's just stretch that down a little bit more. Then we'll make another one. Let's put it about right here. Oops. I'm running out of room here. Let's try it again. Alright, that's pretty good. Alright, so there's my X and Y axis. Remember this? We've talked about this before, haven't we? That's nothing new. That's the x-axis, and that's the y-axis. Let's put a line on here. Actually, let's do this. Let's put a couple points, and then we'll make a line. Let's put a point, like, right here. And let's put a point, I don't know, about right there. All right, there's 2 points. If I have any 2 points, I can always make a line that connects those 2 points, can I? So let's do that. Let's connect that point to this point. And if you wanted to, you could keep on going through, but we'll just stop it right there. Okay? So there's a line right there. And what we have to do is we got to find the slope of this line. and we're going to actually find a number. Okay? Remember what the slope is. It's a fraction, isn't it? Man, I wasn't going to say anything when you were holding that, and I thought for sure there's no way he's going to throw that. But you did. You didn't disappoint, I guess. So get it. He knows what I'm talking about. All right, so look at this. We're going to do rise over run, aren't we? So we're going to take 2 points on this line. Well, I already marked the 2 points here and here, didn't I? All right, so what I need to do, excuse me, is find out how far up and down I go and how far across I go. So let's just count, okay? So you're right here. Let's count. I'll actually draw. Yeah, let's draw it. Just do it in a different color, like green. So what we're going to do is we're going to count from here down to here. Does that make sense on why we go to there? Because it's straight across from the other point. Everybody see that? And now we go from here to that point. We've made a nice little triangle, haven't we? All right. So what do we have to do? We got to count from here to here. It's kind of like, remember the distance formula when we went like x1 or x1 minus y? Let me say x1 minus x2 and then y1 minus y2. It's kind of the same thing, except we're not going to square. We're not going to do square root. All we're doing is trying to find out how far it is from here to here. But let's just count. 1, 2, 3, 4, 5, 6, 7. So that would be 7. Now we went down though, didn't we? We started here and we went down, so this is going to be what 7? It's important. It's -7. That's very important that you keep the sign. Make sure you know which direction you counted. You could have started here, couldn't you? And counted what? Up. And that would have been +7. Make sense? All right, doesn't matter, because the other one's going to make it work. So now we're here, counted 7 down to here. Let's count the other way. 1, 2, 3, 4. But we counted to the left. We went to the left. So what's that going to be? That's going to be negative, isn't it? All right, so let's do the slope. So the slope of this line, we'll do it in green. Slope of the line is rise over run. How far did we rise? We went -7. And how far did we run? We went -4. We're not going to leave it negative over negative. All right, what is negative over negative? It's positive. So let's write the slope as what? +7/4. And that's your slope. Notice I circled it, right? I don't want a decimal. You don't put it into a calculator and get a decimal. You don't even make it into a mixed number. You keep it an improper fraction if it comes out improper. They're not always going to come out improper, but if they do, keep it an improper fraction. Everybody listening? Okay? I want it left like this because I want to see what the rise is and what the run is. If you turn that into a decimal, then you can't really see what the rise and run is. If you make it into a mixed number, you can't see what the rise and run is. But if you keep it as an improper fraction or just as a single fraction, you can see what the rise is and what the run is. I think that's very important. Okay. You could go the other way. You could count up like this. So let's do it this way. I'm not going to put the lines in here, but let's count. 1, 2, 3, 4, 5, 6, 7. But that's a +7, right? And where are we? We're right here, aren't we? And then go what? 1, 2, 3, 4. That's to the right, and that's +4. So it's +7 over +4, which is still 7/4. Does that make sense? So it works out either way you do it. It doesn't matter from which point you start at, which point you end up at. But you got to go from one point to the other. Make sure that you rise first. That goes on top. And the run goes on the bottom. A lot of people get that mixed up. Again, I'm not picking on my honors class, but a lot of people mixed it up. Okay, and they got several problems wrong on the test because they put run over rise. It's not. It's rise over run. Okay, I don't know any fancy way for you to remember it, but it's kind of catchy anyway, right? Just rise over run. If you just say that a few times, rise over run, it just kind of makes sense. We okay with that? Let me show you another way to do this. You could just graph it and count, but they're not always going to give you a graph, and sometimes it won't be very practical to graph the thing. All right, sometimes they'll just give you a couple points. So let's figure out what this point is. What is this point right here? It's 1, 2, 3, 1, 2, 3, 4, 5. So it's what? 3, 5. Everybody see that? What's this point down here? Come on. -1. -2. Good. So it's -1, -2. Make the negative a little bigger. All right. Sometimes they'll do this. Sometimes they won't give you a graph. They'll just give you the 2 points. They'll give you this point, and they'll give you this point right here, and they're going to ask you to find the slope between those 2 points. All right. Let's just figure out how we got this 7 right here. Look at the numbers. Look at this is the rise, isn't it? So which number on your x or on your ordered pair is the rise? Is it the x or is it the y? It's the y, because y goes up and down, doesn't it? Rise goes up and down. So which one is the run? It's the x, isn't it? Okay, so the x is the run, the y is the rise. You follow me? So let's take a look to see how we got -7 or +7, right? Depends on how you subtract. That's it. That's all that matters, okay? So watch. Look at the 2 y values. 5 and what else? -2. Do you see that? So this is at +5, and this is at -2 down here. So you could do what to find the distance between those two? Just subtract them, right? Remember that? Remember a long time ago we went to McDonald's? Remember the trip? And how did you find the distance between the 2 mile markers? You subtracted the 2 mile markers, right? It's the same thing. So this is 5. This is -2. What do you do with 5 and -2? You do what? Subtract them. All right, so it's 5 minus -2. What do you think you're going to do to the... Now, where are you right here? What's that point right here? Actually, let's not even worry about that. Let's just look at the x's. So you're going across now. Look at the x's. So if I went 5 minus -2, what do you think you're going to do to find this? 3 minus -1, right? 3 minus -1. Let's see if those numbers come out to be the same thing as what we got when we counted. What's 5 minus a negative? What's minus a negative? It's plus. So what's 5 plus 2? 7. What's this? Minus a negative again. 3 plus 1 is 4. Look at that. We got the same thing. And we got it without even having to graph it. We didn't really have to graph the thing. If they would have just given me those 2 points right there, how could I find the slope? Just take the y's and do what to them? What did we do with the y's? We subtracted them. Then what did we do with the x's? We subtracted them, didn't we? All right? So that's a lot easier, don't you think, than graphing the line, drawing the up and down and the across, and counting and all that kind of stuff. Because what if you had crazy numbers? What if you went up to like in the 50s or the 70s or the -100s or something? Would you want to graph that? No, obviously not. That would be crazy. So what are you going to do? You're going to take the y's and subtract them from each other, right? In this case, it gave you a 7. And then take the x's and subtract them from each other, and that gave you a 4. Put the y on top and the x on the bottom. So let's write down a little formula for this. I'll do this in purple. Let's write down a little formula for slope. You writing this down? This is really important. So all that stuff kind of led up to this formula. Here's our formula for slope. I put m instead of the word slope. All right? So again, how did we find the up and down? What did we do to those 2 y values? We didn't add them. We did what? We subtracted them. You subtract them to find the distance. If I have 2 points, how can you find the distance between those 2 points? You just subtract them from each other. So I'm going to go y1 minus y2. Now, it doesn't matter what order you subtract them in, as long as you subtract the x's in the same order. So this is the y's, and then what do I do on the bottom then? Subtract the x's. Good. Then I subtract the x's. That is your formula, or your equation, whatever you want to call it. I guess we can call it a formula for the slope. You just subtract the y's, put it on top, subtract the x's, and put them on the bottom. You got to make sure, though, you subtract them in the same order. All right? All right, so here it is. Let me show you just another way. Nope, I'm not going to show you something else. I'm going to just do an example here. Let's find a nice little example. Could just make one up, but all right, here's one. Ready? Write this down. You should be writing all this stuff down. So here's 1 point, 8, -3, and here's another one, -4, -12. You should be writing this down. So here's 2 points, and what are you trying to find? You're trying to. They say find the what? Slope. Find the slope of those 2 points, okay, of the line that's made by those 2 points. So we have a little formula. It's right there, isn't it? What I would do, if I were you, I would write it down every time, just so that you remember it. And after you do it a handful of times, After you write it down a few times, then you remember it. Okay. Remember, it's rise over run, isn't it? Look at the y. The y is the rise, isn't it? And the x is the run. So remember rise over run. Remember the y goes on the top and the x goes on the bottom. All right. Make sure that you remember that, because again, even in the honors class, several people, not just one, several people got it mixed up and put the x on the top and the y on the bottom. All right. So here we go. Let's find the slope. It should be pretty easy. It's kind of like distance formula, except it's a lot less work. All right. It's almost like midpoint formula, and it's even less work than that because you don't have to divide by 2. All you got to do is subtract a couple numbers. That's all you got to do. So what are we subtracting? The y's, right? So subtract the y's. It doesn't matter what order you subtract them in. As long as you subtract the x's in the same order. Did you hear what I just said? That's very important. It doesn't matter what order you subtract the y's in, as long as you subtract the x's in that same order. So I always go like this, the first one minus the second one. That's why I put y1 minus y2. If you look in the book, a lot of books write y2 minus y1. To me, that just confuses students. I don't understand. But I just subtract the x or the y's from each other. So let's subtract them. It's going to be negative 3, what? Minus what? Not minus 12, but minus what? Negative 12. That's very important. Again, that's another place a lot of students get mixed up. They just put negative 3 minus 12. But it's not. It's negative 3 minus negative 12. Let's do the x's now. So now we subtract the x's from each other in the same order, right? So it's 8 minus negative 4. And now you just have to figure out what that is, reduce your fraction, and you're done. It's as simple as that. Finding the slope is very, very easy. So look, minus a negative is plus. Negative 3 plus 12 is positive 9. Right here, minus a negative again is plus. 8 plus 4 is 12. Do we leave it like that? No. Always reduce your fractions. What divides into 9 and 12? 3 does. 3 goes into this 3 times. 3 goes into this 4 times. So your slope is 3 over 4. And that's how you want to write it. There's no dimensions, okay? It's not any kind of a unit. You're not measuring how long the line is or anything else. You're just finding out how steep it is. That means for every 3 that you go up, guess what? You're going to go 4 across. Does that make sense? So if you go up 3 steps, you're going to go over 4 steps. That's the slant of that line. Did I have to graph it at all to find that slope? No, I didn't. I didn't have to graph it. Okay, so these could have been real big, crazy numbers. And I could have still found the slope very, very easily. Didn't have to graph it. That's the slope of the line. And it's positive, so you know which direction it's going to go. You know it's going to rise 3, and it's going to run 4. And that tells you a lot of stuff. Okay, this slope can be very important. And you're probably thinking, well, who cares about slopes? I mean, when are we ever going to use this? In the sciences, you use slopes all the time. It's very, very, very important. When you're doing experiments and you're collecting data, or data, whatever you want to call it. Okay, I say data. But if you collect data and you get all these numbers, you want to see the relationships between all those numbers in your experiment, what's going on. So what do? They graph the lines. And the slope of that line is a very, very important number to the scientists and the people that are doing that particular experiment. All right? And you might do that stuff as you get a little older and start doing some more science kind of thing. All right? So that's that. Let's talk a little bit more about this. All right, we're back to the black background again because with all those lines and stuff, all these little grid mark lines, I thought it'd be easier to do it on this background. So let's take a look at this. If I had a line like this, now watch what I'm going to do. I'm going to copy it and I'm going to paste it. So what must be true about these two lines then? They're parallel. What's that? Right, you don't know yet, but I did say I copied and pasted it. Okay, if I copy and paste it, then it's exactly the same line, and so guess what? They are what? Parallel to each other. Okay, so I do know that they're parallel just because of the way that I made that line. All right? But you're right. Summer is right. If you just looked at those two lines and you didn't know that I copied and pasted it, you wouldn't know that they're parallel until somebody told you. And they are, okay? They are parallel to each other. Now, what do you think might be true about the slopes of these two? Look, if I took 2 points right here and I rise and I run, oops, that wasn't a very good run, was it? But anyway, you get the idea. If I rise and I run, it's going to be the same exact slope. Is this one slanted any more or less than this one right here? No. Now, one's a little higher than the other, right? But they're not slanted anymore. All right, so they have the same slope. So let's write this down. This is very, very important. So parallel lines have, we'll say, equal slopes. All right, they have the same slope. So two lines that are parallel to each other have the exact same slope. Got it? All right, and we're going to be talking about this later. I mean, you did this in Algebra 1. Remember you did equations of a line. Remember y equals mx plus b? Remember that stuff? We're eventually going to get to that. We're just not going to do that today. All right, but this parallel line thing is pretty important. So parallel lines have the same slope. Now look at this. What if you had a line like this and a line, I'm going to try to, I have to eyeball it, but that's pretty close. And actually, let's extend this down just so it doesn't stop right there on that line. And what if I put a little box right there? It's a right angle. But what's true about the lines? What do we, yeah, it's 90 degrees, but what's true about the lines? What do we say? Well, they do intersect, but there's a lot of lines that intersect. They're perpendicular. Look, those two lines intersect, but they're not perpendicular, right? So these two lines more specifically with that right angle are perpendicular. All right, so perpendicular. We've talked about that word before, haven't we? Yes, we have. So perpendicular lines. Now watch this. Look at the slopes. Look at this one right here. Do they have the same slope? Obviously not. Look at this first line right here. Is that positive or negative? It's positive, isn't it? Because it's going up from left to right. What about this line right here? It's negative, so it's going down. Now look at this one. Do they look about the same steepness? If you went skiing, right? So look, you're skiing. There's me skiing again. Whee! There's me skiing. It looks like I'm sledding on my butt or something, okay? But anyway, so if you're skiing and going down this one, which one looks steeper?
That one.
This one right here. Now there's nothing undefined because it's not vertical. It's not vertical, okay? But let me, boom. Boom. There's my, and then there's my arms. Okay. So now which one is steeper? Let's call it L and M. So which steeper? M is a lot steeper, isn't it, than what L is. In fact, they're actually inverses of each other. So let's pretend, I don't know what this is, but let's pretend the slope of this one was 1/2. Okay? The slope of this line right here, it's negative, but it's also the inverse of 1/2. So what's the inverse of 1/2? If I flip it, it's 2/1. So the slope of this line would be -2. Do you see that? So perpendicular lines are, well, the slopes, let's say this, the slopes of perpendicular lines, here's how I say it. I say negative, and I use this word, reciprocal. Remember this? I need a P on there, don't I? Reciprocal. There we go. That's right. Reciprocal. That's it. So negative reciprocals. That's the phrase that I use. Negative means the opposite sign. Reciprocal means you do what to the fraction? You flip it. Okay? So watch this. If I said the slope of one line was 3/4, what would the slope of a line that's perpendicular to this one be? Very good. It's -4/3. It's as easy as that. You see it? So if I told you the slope of a line, and then I said, okay, what would the slope of a line that's perpendicular to that line be? What do? You change the sign, and you flip the fraction. That's all you do. You change the sign, and you what? Flip the fraction. Okay? So if the slope of one line is 3/4, the slope of the perpendicular line is going to be -4/3. What about the slope of a parallel line to 3/4? Okay, it's going to be 3/4 again. Because remember, the slopes of parallel lines are what? Are exactly the same. All right, so if this is the slope that we're starting with, a perpendicular line is going to be -4/3. A parallel line is going to be exactly the same. It's going to be 3/4. Okay? Let's do a couple others. Watch this. What if the slope of a line was -7/3? What would the slope of a perpendicular line be? That's it. It's +3/7. See how easy that is? Very, very simple. What if you had the slope of a line that was just 3? What's the slope of a perpendicular line to this? It's negative. You got to flip it. You got to flip. 3 is 3 over 1, so you got to flip 3 over 1, which gives you 1 over 3. That's a little bit tricky, okay? That's not hard, though, because 3 is 3 over 1, right? So what do? You take the opposite sign, and then you flip the fraction. Got it? What if I had this? What if I had the slope of a line was negative 5/7? What is the slope of a parallel line to this? It's the same exact thing, all right? It is easy. It's very simple, okay? But a lot of people get this confused. But it is pretty easy. So if the slope of a line is negative 5/7, the slope of a parallel line is going to be negative 5/7. It's going to be the same thing, negative 5/7. What if I wanted to find the slope of a perpendicular line to this? It'd be positive 7/5. Got it. All right? You just got to keep straight which one's which. And go back to this. Mentally think about this. If the lines are perpendicular, think about me skiing down both of these hills. They're not going to be the same slope, are they? This is the bunny slope right here. This is not as steep. This is the double black diamond right here. This is really steep going down this one. Okay? It's not undefined though, is it? But let's talk about that for a second. We got a couple minutes here. Let's talk about the slope of a vertical line and the slope of a horizontal line. What's true about a horizontal line and a vertical line? They're what? They're perpendicular, aren't they? So guess what must be true about their slopes? The slopes. They're negative reciprocals of each other, okay? So what is the slope of this line right here? Without any numbers at all, what is the slope of this? It's 0, isn't it? Okay, the slope is 0. All right. Now, what's another way we could write? We could write 0 all kinds of ways. We could write 0 over anything, couldn't we? Let's just pick a number. Let's say 5. Okay? We'll make it easy. All right, so we'll say 0 over 5. Now, what would the slope of a perpendicular line to this be? Well, you change the sign, but really, does changing the sign really do anything? No. So it would be what? Put that in a calculator. Anybody got a calculator out? Put that in a calculator. I don't care if you put negative or positive. You still get the same thing. Error. So it's an error, which means it's what? It's undefined. So check this out. Would you agree that the slope of a horizontal line is the negative reciprocal of a parallel line? Or of a, I'm sorry, what did I say? Slope of a horizontal line is the reciprocal of the slope of a vertical line. That's what I'm trying to say. All right? Does that make any sense? All right, so you can still see that everything works out just like we said it was. All right? And they're perpendicular. Got that? I think we're good. Let me check the worksheet, see if I missed anything. Okay, watch this. We got a couple minutes, so I'm going to do this a little bit quick, but you can always look at it on here. So that's point A. Write this down. Point B is 4, 4. Point C is 9, negative 10. And then point D is negative 6, negative 5. Now here's what they ask. They give you 4 points right here. And they're going to say, tell me something about line AB and line CD. Okay, tell me if they're parallel to each other, if they're perpendicular to each other, or if neither one of those things is true. So how in the world would I know if these are perpendicular to each other? What do I look for? I look for their what? Slope. That's right. So let's find the slope of AB. Here's line AB. Let's find the slope of AB. I'll put a little AB right there. All right? That's supposed to be a B. So let's do it really quick. How do we find the slope? Subtract the y's, right? So it's 5 minus 4, and then it's 1 minus 4. Look how easy it is to find the slope. That's 1 over negative 3. So that's the slope of AB. But now what do we have to find? The slope of CD. So let's find the slope of CD. Again, it's negative 10 minus, not 5, minus negative 5. Right? Minus negative 5. And then it's what? 9. Hold on just a second. Let me finish this up. So this is negative 5 over 15, which is what? Negative 1/3. Now look, tell me something about these two lines.
They are
Perpendicular.
parallel.
Look at them. They're parallel. Right. They are parallel. Let me give you a worksheet before you
I
go.
already got mine yesterday.